We have pointed a time machine at the dark, and the dark has stared back with something that simply should not be there. When the James Webb Space Telescope opened its golden eye, we expected to see the birth of the universe. We expected to see the cosmic dawn. The standard model of cosmology, the rule book we have used for 50 years to understand everything from atoms to black holes, gave us a very specific prediction. It told us that if we looked back far enough to the very first few 100 million years after the Big Bang, we would find a chaotic, messy nursery. We should have seen small, dim clouds of gas just barely beginning to collapse into the first stars. We should have seen the universe in its infancy, clumsy, unformed, and quiet. But we didn't see that. Instead, we saw monsters. We looked into the crib of the universe, expecting to find a sleeping baby, and instead, we found a fully grown man with a grey beard staring back at us. This is not just a surprise. This is a crisis. The galaxies James Webb has found in the deep silence of the early universe are too big, too bright, and too mature to exist. By every law of physics we currently understand, they should not be there. They are impossible. And yet, there they are, burning with a brightness that defies logic, mocking our models, and telling us that the story we have told ourselves about the origin of everything might be wrong. Let's look at the evidence. Let's look at the crime scene. One of the most disturbing culprits is a galaxy named Jade's GSZ 140. Now, names like that usually make people tune out, so let's give it a proper identity. Let's call it the impossible giant. This galaxy is located roughly 290 million years after the Big Bang. Now, in human terms, that sounds like a long time, but in cosmic time, that is the B of an eye. That is seconds after the starting gun. At that point in history, the universe was still dense with hydrogen fog. It was the cosmic dark ages. Gravity was supposed to be weak and slow, gently pulling atoms together to form the first tiny, fragile stars. A galaxy at this time should be a smudge. It should be a ghost. But Jade's GSZ 140 is not a smudge. It is massive. It is hundreds of millions of times the mass of our sun. It is shining with a luminosity that suggests it is full of mature stars, stars that have already lived and died and enriched their surroundings with heavy elements. Here is a number that might scare you. To build a galaxy this big, this early, the gas would have had to collapse into stars with almost 100% efficiency. That means almost every single atom of hydrogen in that region of space had to instantly turn into a star without wasting a single drop. That is physically impossible. Stars don't form like that. Star formation is messy. It's inefficient. Winds from new stars blow gas away, stopping the process. It's a self-regulating system. So, how did this happen? How do you build a skyscraper in 5 minutes? The existence of this galaxy suggests that gravity in the early universe was behaving in a way we do not understand. It suggests that things grew faster, harder, and more violently than our mathematics say is allowed. It's as if someone pressed the fast-forward button on evolution. Now, ask yourself, what if the timeline is wrong? What if the Big Bang didn't happen when we think it did? This is where the midnight scholar in all of us has to wake up. We are looking at a smoking gun. If you find a 50-year-old oak tree in a garden that was planted yesterday, you have two options. Option one, the tree grew miraculously fast. Option two, the garden is older than you think. For decades, we have been confident that the universe is 13.8 billion years old. We have measured the cosmic microwave background radiation, the afterglow of the Big Bang, to an incredible precision. We thought we had the age of the universe pinned down to a decimal point, but these universe breaker galaxies are challenging that confidence. Some rogue physicists are already whispering that maybe the universe is twice as old as we thought. Maybe it's 26 billion years old. Maybe the tired light theory, an idea discarded decades ago, needs to be taken off the shelf and dusted off. I don't think we need to go that far just yet, but the tension is real. The anxiety in the scientific community is palpable. You can hear it in the papers being published. They use polite words like tension and anomaly, but what they really mean is panic, because it's not just one galaxy, it's dozens of them. We are finding red dead galaxies in the early universe. These are galaxies that have already finished making stars and have gone to sleep. They are retired. How do you retire when the universe has just begun? How do you have a galaxy that looks like it has lived a full life when the universe itself is still in diapers? This brings us to a terrifying realization about our place in things. We have always assumed that we understand the script. We are the wise observers, sitting at the end of time, looking back, piecing together the puzzle. We thought the puzzle was mostly finished. We thought we just had a few edge pieces left to slot in. Dark matter, dark energy, a few details about neutrinos. But James Webb has taken the puzzle board and flipped it over. Let's go deeper into the physics of why this is so impossible. To understand the scale of this problem, you have to understand how we see the past. We don't see the universe as it is, we see it as it was. Light takes time to travel. When you look at the moon, you are seeing it 1.3 seconds ago. When you look at the sun, you are seeing it 8 minutes ago. If the sun exploded right now, you wouldn't know for 8 minutes. You would be sitting there, drinking your coffee, enjoying the warmth of a ghost. When James Webb looks at Jade's GSZ 14-0, it is catching photons that have been traveling for more than 13 billion years. These photons have been swimming through the expanding dark, stretching out as they travel. This stretching is what we call redshift. The further away something is, the more its light is stretched towards the red part of the spectrum. We use this redshift as a ruler. We measure how much the light has stretched, and that tells us how far away the object is and how long ago that light was emitted. But here is the catch. This ruler depends on the universe expanding at a predictable rate. It depends on us knowing the history of that expansion. If the universe expanded differently in the past, or if the early universe had different rules, our ruler is broken. And if our ruler is broken, we are lost in the dark without a map. This is the crisis in cosmology. It's not just about some distant galaxies being a bit too big. It's about the fundamental geometry of space and time. It's about whether we actually know what is going on. Imagine you are trying to measure the size of a room, but the tape measure in your hand is constantly changing length, and you don't know by how much. That is the situation we are in. And it gets worse, because these early impossible galaxies are not just big, they are shaped Strangely, in the local universe, galaxies are often beautiful spirals, like our Milky Way, or big fuzzy ellipses. They are symmetric, they are orderly. But the things James Webb is seeing in the deep past are often flattened, like cigars or surfboards. They are dense, compact, and weirdly geometric. Why would the first structures in the universe be surfboard shaped? Some theories suggest this might be due to the nature of dark matter. We have never seen dark matter. We don't know what it is. We only know it exists because without it, galaxies would fly apart. Gravity isn't strong enough to hold them together based on the visible stars alone. There must be an invisible glue. In the early universe, this dark matter might have formed long filaments, a cosmic web, and the gas, the normal matter that makes up you and me and the stars, flowed along these filaments like water in a pipe. This could explain the surfboard shapes. The galaxies were forming inside these massive rivers of invisible gravity. But if that's true, the concentration of dark matter required to make jades GSZ 140 is staggering. It would mean the early universe was lumpy, really lumpy. The standard model says the early universe should be smooth. The cosmic microwave background, that baby picture of the universe, is incredibly smooth. It's almost perfectly uniform, with only tiny ripples in temperature. So how do you get from a smooth, uniform baby soup to a lumpy, monster-filled teenage universe in such a short time? It's like starting with a perfectly flat lake and 5 minutes later finding Mount Everest sticking out of the water. Where did the mountain come from? What pushed it up? This leads us to a darker possibility, a possibility that echoes the melancholy truth Brian Cox often alludes to. We might be missing something fundamental about the nature of reality itself. Perhaps gravity was stronger in the past. Perhaps the speed of light wasn't constant. Perhaps the constants of nature are not constant at all. If the laws of physics evolve over time, then looking back at the Big Bang is like trying to read a book written in a language that is slowly changing as you read it. By the time you get to the first page, the words mean something completely different. This uncertainty is humbling. It reminds us that for all our telescopes, for all our supercomputers, we are still just primates on a small rock, peering out into a void that is far larger and far stranger than our brains are designed to comprehend. We call ourselves observers. We think we are the audience watching the show, but we are realizing that we walked into the theater in the middle of the third act, and we are trying to reconstruct the beginning of the play just by looking at the set design, and the set design is confusing us. Let's take a step back from the data and feel the weight of this. Think about the light from Jade's GSZ 140. It started its journey before the Earth existed, before the sun ignited. It traveled through the void while our solar system was just a cloud of dust. It kept traveling while the dinosaurs rose and fell. It kept traveling while humanity evolved, while we built the pyramids, while we invented the steam engine, while we fought our wars. And finally, after 13.5 billion years, it hit a gold-coated mirror a million miles from Earth. That light carries a message. It says, "We were here, we were huge, and we don't fit your rules." The sheer violence implied by these galaxies is also worth noting. To be that bright, they must be producing new stars at a rate that would tear a normal galaxy apart. Supernovae would be going off like popcorn. Black holes would be feeding frenzies, spewing jets of radiation that drill through the cosmos. The early universe was not the quiet dark we imagined. It was a fireworks display of cataclysmic proportions. And yet, in all that fire, in all that creation, we see no sign of engineering. We see no Dyson spheres. We see no patterns that look artificial. We see only the raw, brutal machinery of nature. This reinforces the isolation. Even when we look at the most impossible objects, they are impossible because of physics, not because of aliens, the universe breakers, and natural disasters, not civilizations. Now, let's pivot to another mystery that James Webb has illuminated, one that is equally troubling: the Hubble tension. I mentioned the broken ruler. This is where the ruler snaps in half. We measure the expansion rate of the universe, the Hubble constant, in two ways. One way is to look at the beginning, the cosmic microwave background, and project forward. The other way is to look at the local universe, at supernovae and pulsing stars, and measure backwards. These two numbers should match. If our model of the universe is correct, they have to match. It's like measuring a bridge from the left side and the right side. You should get the same length. But we don't. The measurements disagree, and they disagree by a lot. The universe is expanding faster nearby than it should be based on the beginning. For years, astronomers hoped this was just a mistake, a smudge on the lens, a calibration error. Maybe we are measuring the supernovae wrong, they said. James Webb was supposed to fix this. With its perfect vision, it could measure the stars more accurately than Hubble ever could. It would resolve the tension. It would show us that the numbers actually do match, and we can all go back to sleep. But James Webb didn't do that. James Webb confirmed the tension. It looked at the stars, measured them with perfect clarity, and said, no, the discrepancy is real. The universe is actually tearing itself apart faster than your laws of physics can explain. So, we have two massive problems colliding at once. Problem one: the early universe is too heavy, too bright, and too mature. Problem two: the modern universe is expanding too fast. It feels like the universe is mocking us. It's growing too fast at the beginning and expanding too fast at the end. It's a runaway train. But what if we are looking at this upside down? What if these two problems are actually the same problem? What if the dark energy that is driving the expansion today was also doing something strange in the beginning? What if there was a precursor to dark energy, a theoretical field called early dark energy that flared up briefly, injected a burst of speed into the cosmos, and then vanished? That would explain why the baby universe looks so old. It was accelerated. It was aged artificially by a force we can't see. This is the detective story we are living in. We are hunting for a ghost force that existed 13 billion years ago, left its fingerprints on the galaxies, and then disappeared. And where does that leave us? It leaves us standing on the edge of a precipice. The standard model of cosmology, the Big Bang Theory as we know it, is shaking. It hasn't collapsed yet, but the cracks are visible, and through those cracks we can see a light that is brighter and stranger than anything we prepared for. The James Webb Telescope was built to answer questions. Instead, it has questioned our answers. It has humbled us. It has shown us that the universe is not a solved problem. It is a wild, untamed place where the rules can change, where galaxies can grow up overnight, and where the dark is full of impossible things. We are not the masters of this domain. We are the confused tourists. As we move forward into this investigation, we need to talk about the tool that is revealing all of this, the telescope itself. It is a marvel of human engineering, perhaps the greatest machine ever built. It sits at a point in space called L2, a gravitational sweet spot where the Earth and Sun cancel each other out. It is freezing cold, protected by a sun shield the size of a tennis court. It is listening to the whispers of the past. But the message it is hearing is getting louder. It's a siren, and that siren is telling us that our map of reality is drawn wrong. We have spoken about the impossible galaxies. We have spoken about the broken ruler. But there is a third piece of evidence that is just as disturbing: the black holes. In the centers of these impossible galaxies, we are finding supermassive black holes, monsters that are millions or billions of times the mass of the sun. Now, a black hole takes time to grow. It has to eat. It eats gas, dust, stars. But there is a speed limit to how fast it can eat. It's called the Eddington limit. If a black hole tries to eat too fast, the radiation from the infalling matter blows the food away. It chokes. So, how do you get a billion solar mass black hole when the universe is only a few 100 million years old? Even if it started eating the moment the Big Bang happened, and ate as fast as physically possible without stopping, it shouldn't be that big yet. It's like finding a 500-pound tiger cub that was born yesterday. Unless they didn't start as small black holes. Unless they were born big. This is the theory of direct collapse. The idea is that in the early universe, massive clouds of gas didn't bother forming stars. They just collapsed directly, instantly, into a giant black hole, a hole in reality that simply appeared. If this is true, it paints a terrifying picture of the early cosmos. Not a place of slow, gradual evolution, but a place of sudden, violent collapses. A place where the fabric of space-time was puncturing itself spontaneously. James Webb is seeing evidence of this. It is seeing black holes that are too big for their galaxies. Usually, a galaxy and its black hole grow together, like a body and a heart. But these early galaxies are like small bodies with gigantic hearts beating too hard. The universe was born with heart disease. This finding aligns with the Midnight Scholar perspective. We are uncovering a history of violence. The universe did not gently wake up. It screamed into existence. And we are the only ones around to hear the echo. As we close this first chapter of our investigation, look at that image of the deep field again. Really look at it. Those specks of red light are not just stars. They are entire systems of billions of stars, burning with a ferocity we can scarcely imagine. They are the ancestors of our own Milky Way. They are the ghosts of the dawn. They are telling us that we are wrong. And being wrong is the most exciting thing a scientist can be, because being wrong means there is more to discover. It means the book isn't finished. But if the ruler is broken, and the clock is wrong, and the map is inaccurate, how do we measure the darkness? How do we make sense of the void? We have to look at the expansion itself. We have to look at the redshift not just as a measurement, but as a phenomenon that is dragging us away from the truth. The universe is stretching, and it is taking the answers away from us. In the next part, we are going to look at this stretching. We are going to look at the broken ruler in detail. We are going to confront the terrifying reality that the universe is not just getting bigger, it is disappearing. The horizon is shrinking. The galaxies are running away. And we are going to ask the question, if the universe is running away from us, are we finally, truly, and completely alone? If the universe is running away from us, are we finally, truly, and completely alone? To answer that, we have to talk about the siren. Imagine you are standing on a street corner in the middle of the night. It is perfectly silent. Then, in the distance, you hear the wail of a police car as it screams towards you. The pitch is high, sharp, and urgent. But the moment it passes you and speeds away into the dark, the sound drops. It stretches out. It becomes lower, deeper, almost a moan. That drop in pitch is the Doppler effect. The sound waves are being physically stretched by the speed of the car running away from you. Now, imagine that the police car is a galaxy and the sound it is making is light. When James Webb looks into the deep universe, it sees galaxies that are rushing away from us at speeds that defy comprehension because they are moving away. Their light is stretched. Blue light becomes yellow. Yellow becomes red. Red becomes infrared. This is redshift. It is the visual sound of the universe screaming as it runs away from us. And the further we look, the faster they are running. This is not just a metaphor. This is the fundamental mechanic of our isolation. The universe is not a static stage where actors move around. The stage itself is growing. The floorboards are stretching. The space between the Earth and the Moon is stretching. Though gravity holds it together, the space between us and the nearest galaxy is stretching. But here is the twist that keeps cosmologists awake at night. We thought we knew how fast the stage was stretching. We have a number for it. We call it the Hubble constant. It is the speedometer of the universe. For 50 years, we have been trying to read that speedometer. And for 50 years, we have been getting two different answers. One group of scientists looks at the baby universe, the cosmic microwave background, and calculates how fast the universe should be expanding today. They get a specific number. Let's call it 67. Another group of scientists looks at the local universe, at supernovae and pulsating stars nearby, and measures how fast it is actually expanding. They get a different number. Let's call it 73, 67, 73 in a math class. Those numbers are close. In physics, that difference is a canyon. It is a catastrophe. It means that either our understanding of the beginning of the universe is wrong, or our understanding of the modern universe is wrong. We built the James Webb Space Telescope to settle the argument. We thought, surely, the local measurements are just a bit fuzzy. Hubble had a cataract. Webb has perfect vision. Webb will look at those stars, refine the data, and the number 73 will drop down to 67. Order will be restored. The laws of physics will be safe. but the universe had other plans. Webb looked, it measured, and it came back with a number that was even more confident. It said, essentially, I am not mistaken. The local universe is expanding at 73. The early universe predicts 67. Deal with it. This is the Hubble tension, and it suggests that something is pushing the universe apart faster than it should be. But what if we are looking at this upside down? What if the universe isn't just getting bigger, but the space between your atoms is trying to tear you apart? We call this force dark energy, but giving it a name is just a way of hiding our ignorance. We don't know what it is. All we know is that it makes up 70% of the universe. 70% of reality is a mysterious pressure that is trying to stretch the cosmos to death. And because of this tension, because of this acceleration, the universe is slowly disappearing. Think about the horizon. If you stand on a beach, you can see a ship until it drops over the curve of the Earth. In the universe, there is a cosmic horizon. It is the distance at which space is expanding faster than the speed of light. If a galaxy is beyond that horizon, its light can never reach us. It is moving away faster than the message can travel. And because the expansion is accelerating, that horizon is shrinking. It is closing in. Every second, millions of stars cross that line and vanish from our observable reality forever. They are being deleted from the sky. This creates a profound sense of claustrophobia. We usually think of space as infinite, but for all practical purposes, it is a prison cell that is getting locked from the outside. The galaxies we see today, the ones James Webb is photographing, are the last ones we will ever see. We are living in a privileged moment in history where the sky is still full of light. Billions of years from now, if there are astronomers living on a planet around a dying red sun, they will look up and see nothing. Their galaxy will be the only thing visible. The rest of the universe will have accelerated away into the dark. They will think they are the entire universe. They will have no evidence of the Big Bang. They will have no evidence of other galaxies. They will think the cosmos is static, small, and lonely. We are the only witnesses who will ever know the truth. Now, ask yourself, if the ruler we use to measure reality is broken, do we actually know where we are? This brings us back to the impossible galaxies from part 1. If our ruler, redshift, is being manipulated by a force we don't understand, can we trust the distances? When we say a galaxy is 13 billion light years away, we are assuming that light has traveled a straight path through a predictable expansion. But if the expansion has been jerky, if it started fast, slowed down, and then sped up again, that distance might be an illusion. We might be like a sailor navigating by a map that stretches and shrinks while he looks at it. This uncertainty forces us to confront the limits of human knowledge. We have this arrogance that we can understand the machine. We built the Large Hadron Collider to smash atoms. We built Webb to catch ghosts. But the machine is bigger than us. Let's go deeper into the ghost concept. When you look at your hand, you see it as it is now. The light travel time from your hand to your eye is negligible. You live in the present. But when James Webb looks at a galaxy, it is not seeing the galaxy. It is seeing a fossil. It is seeing a memory. Light is not a courier. It is a jailer. It tells us that we are always looking at ghosts. This is the speed of light problem. It is the ultimate speed limit of the universe, and it is painfully slow. 300,000 kilometers per second sounds fast to a human, but on the scale of the universe, it is a crawl. It is a snail pace. To cross our own galaxy, the Milky Way, takes light 100,000 years. That means if there is a civilization on the other side of our own galaxy and they send us a message saying hello, we won't get it for 100,000 years. By the time we reply hello back, another 100,000 years will have passed. Our species might be extinct. Their species might be extinct. Conversation is impossible. Connection is impossible. We are trapped in our own little bubble of time. James Webb has revealed that this bubble is even more isolated than we thought. By showing us the sheer scale of the early universe, it has shown us how much we are missing. We are seeing galaxies that lived and died before Earth was even born. We are seeing star clusters that burned out billions of years ago. We are walking through a graveyard, a beautiful, glittering graveyard, but a graveyard nonetheless. And in this graveyard, we find the standard model of cosmology struggling to breathe. Let's talk about what happens if the model breaks. If the Hubble tension cannot be resolved, if the universe really is breaking the rules, then we need new physics. We need a new Einstein. Some theories are already popping up. One is modified gravity, or MOND. This theory suggests that dark matter doesn't exist. It suggests that our understanding of gravity is wrong on large scales. It suggests that Newton and Einstein were right about apples and solar systems, but wrong about galaxies. If MOND is true, then the universe is not full of invisible ghosts. It is just operating under a different law. Another theory is tired light. This is an old idea, long rejected, that says light loses energy as it travels, not because space is expanding, but just because it gets tired. It interacts with particles in the void and loses its punch. If this were true, the universe wouldn't be expanding at all. It would be static. If the universe is static, then the Big Bang never happened. James Webb has actually given some ammunition to the tired light theorists. The fact that the early galaxies are so small and dense fits better with a static universe than an expanding one. Imagine the chaos if that were true. Imagine if we had to rewrite every textbook from the last 100 years. Imagine if we had to tell the public, actually, the universe didn't begin 13.8 billion years ago. It has always been here. Eternal, unchanging. That is unlikely. The evidence for the Big Bang is still overwhelming, but the fact that we are even whispering about it shows how much James Webb has shaken the foundations. It is a midnight scholar's dream. The clues don't fit. The suspect, the universe, is lying to us. Let's look at another piece of evidence that James Webb has thrown onto the table: the chemical composition of these early things. We expected the first stars to be made of pure hydrogen and helium, the pristine stuff of the Big Bang. We call these population 3 stars. They are the holy grail of astronomy. We have never seen them. Webb has looked, and it has found carbon, oxygen, neon. It has found heavy elements in galaxies that are supposed to be pristine. Where did the neon come from? Heavy elements are made in the hearts of dying stars. It takes millions of years to cook them. If the early universe is already full of pollution, full of dust and heavy metals, then generations of stars must have lived and died instantly. This implies a universe that was frantic. It wasn't the slow, majestic unfolding we see in planetariums. It was a mosh pit. It was a violent, rapid fire cycle of birth and death. This violence brings us back to the fragility of Earth. We live in a quiet neighborhood. Our sun is a middle-aged, boring star in a quiet arm of a spiral galaxy. We are protected. We are sheltered from the chaos. If we lived in one of those early galaxies, life would be impossible. The radiation would sterilize the planet. The supernovae would strip the atmosphere. The black hole in the center would be spewing X-rays that would fry our DNA. We exist because we are late. We exist because the universe has calmed down. We are the beneficiaries of a cooling cosmos. This is a crucial perspective shift. We often lament that we missed the party. We missed the early days. But we didn't miss the party. We missed the war. We are walking through the battlefield after the smoke has cleared. The impossible galaxies are the craters left by the bombs. And now let's talk about the Great Wall. When we map these galaxies, we don't just see random dots, we see structures. James Webb is helping us trace the filaments of the cosmic web in high definition. We see that galaxies are not scattered like sand, they are strung like pearls, they follow invisible highways. But between these highways, there are gaps, voids, the Boötes void, the Eridanus supervoid. These are regions of space, millions of light years across, where there is almost nothing, no galaxies, no stars, just cold, empty, dark. If you were dropped into the middle of a void, you would see nothing. The sky would be black. You wouldn't even see the Milky Way. You would be truly alone. James Webb is showing us that these voids were there from the beginning. The universe cracked open very early. This structure, the web and the void, tells us something about the creation event. It tells us that the Big Bang wasn't a smooth explosion. It was a quantum event. The tiny, microscopic jitters of the quantum world were blown up to the size of the cosmos. When you look at a galaxy, you are looking at a fossil of a quantum fluctuation. You are looking at a subatomic particle that got blown up to the size of 100,000 light years that connects us to the small. The very big is just a reflection of the very small. And where are we in this web? We are in a filament. We are in a stream of matter flowing towards a gravitational center. We are moving at 600 kilometers per second towards a mysterious point in the sky called the Great Attractor. We don't know exactly what it is because it is hidden behind the dust of our own galaxy, but something out there is pulling us. Something massive, something terrifying. It is pulling the Milky Way. It is pulling Andromeda. It is pulling thousands of galaxies. James Webb, with its infrared eye, can peer through the dust a little better. It is helping us map the flow, and it turns out the Great Attractor might just be a node in the web, a supercluster of galaxies. But there is something even bigger beyond it. The Shapley supercluster. And beyond that, we don't know, because the ruler is broken. We are being dragged across the universe by a gravity we can't fully map, in a space that is expanding faster than we can measure, towards a destiny we cannot see. This is the state of cosmology in 2025. We are not the masters of the universe. We are corks bobbing in a storm, and the storm is getting stronger. As we stare into this chaotic, accelerating abyss, we have to ask a very human question. If the universe is so hostile, so large, and so broken, why does it look so beautiful? Why is the Orion Nebula a masterpiece of art? Why are the pillars of creation so majestic? Brian Cox often speaks of meaning. He suggests that meaning is not something we find in the universe, it is something we bring to it. The universe doesn't care about beauty, it only cares about gravity and thermodynamics. But we care. We look at the cosmic cliffs in the Carina Nebula, an image captured by Webb, and we weep. We see mountains of gas, glittering with baby stars. We see a landscape. Our brains are designed to find patterns. We evolved to find fruit in the trees and predators in the grass. So when we look at the gas clouds of the early universe, we see cathedrals, we see faces, we see gods. But James Webb is showing us the raw data. It is stripping away the romance and showing us the mechanics. The cosmic cliffs are not mountains, they are walls of hydrogen being eroded by ultraviolet radiation. It is a scene of destruction, not just creation. The baby stars are eating their nursery. It is a violent beauty. And this brings us to the edge of the map. We have talked about the impossible galaxies. We have talked about the broken ruler of redshift. We have talked about the void. But there is one thing we haven't talked about yet. The structure that holds it all together, the invisible skeleton. To understand why the universe looks the way it does, we have to look at the nothing. We have to look at the space between the stars, because it turns out the nothing is heavy. The nothing is what is shaping us. In the next part, we are going to leave the galaxies behind and dive into the cosmic web itself. We are going to explore the great voids. We are going to visualize what it would be like to float in the empty spaces where the universe has failed to create anything. And we are going to confront the scariest thought of all. The universe is mostly empty, and the places that aren't empty are trying to kill us. So do not think of space as an ocean. An ocean has water. Space has nothing. It is the absence of the possibility of life. Let's step into the void. When we step into the void, the first thing we notice is that the darkness has a shape. For a long time, we thought the universe was like a loaf of bread with raisins scattered evenly throughout it. The raisins were the galaxies, and the dough was the space between them. We thought that if you looked at a big enough chunk of the universe, it would look the same everywhere. Uniform, boring. But James Webb has helped us map the dough, and it turns out we were wrong. The universe is not a loaf of bread, it is a spider web. It is a vast, three-dimensional lattice of dark matter and gas, stretching across billions of light years. This is the cosmic web, the galaxies, the billions of stars, the black holes, the nebulas, are not scattered randomly. They are clinging to the strands of this web, like dewdrops on a spider's silk in the morning. They are huddled together in clusters and superclusters, flowing along rivers of invisible gravity. But between the strands, there are the holes, the great voids. These are the places that truly terrify the midnight scholar. These are the places where the universe has failed to create. Imagine you are in a spaceship traveling through one of these filaments. You are surrounded by light. You have neighbors. The Andromeda galaxy is next door. The Virgo cluster is down the street. It feels busy. Then you take a turn and head out into the emptiness. You travel for 1 million years, then 10 million, then 100 million, and you see nothing. One of the largest of these empty spaces is the Boötes void. It is a sphere of nothingness, roughly 330 million light years across. To give you a sense of scale, our entire Milky Way galaxy is only 100,000 light years across. You could fit thousands of Milky Ways inside this void, and they would never touch. If you were dropped into the center of the Boötes void, and you looked out with your naked eye, you would see absolute, crushing blackness. There would be no stars, no band of the Milky Way, no comfort. In fact, if the Earth had been unlucky enough to evolve inside the Boötes void, we would not have known that other galaxies existed until the 1960s. We would have thought the entire universe consisted of just our own galaxy, floating alone in an infinite dark box. We would have had no concept of the cosmos, no concept of the Big Bang, no concept of expansion. We would have been cosmically blind. But James Webb is showing us that these voids are not just empty, they are growing. They are the expanding bubbles in the cosmic foam. As the universe accelerates, the voids get bigger, and they squeeze the matter into tighter and tighter filaments. The universe is segregating itself. It is separating the light from the dark. Here is a visualization to help you understand just how lonely these spaces are. If you shrank the sun down to the size of a grain of sand, the nearest neighbor, the star Alpha Centauri, would be 4 miles away. That is the density of a crowded galaxy. Now, imagine that same grain of sand in a cosmic void. The nearest neighbor would not be 4 miles away. It would be on the other side of the planet. This vastness changes how we must think about our environment. We love to use nautical metaphors. We call our ships spaceships. We call our travelers astronauts, which means star sailors. We imagine space as an ocean that we can cross, but do not think of space as an ocean. An ocean has water. It has substance. It has buoyancy. If you fall into the ocean, you are held up by something. Space has nothing. It is the absence of place. There are places in the universe so empty that if you were teleported there instantly without a spacesuit, you wouldn't even freeze instantly. Why? Because there are no atoms to steal your heat. Heat transfer requires a medium. In the deep voids, there is no medium. You would eventually freeze by radiating your heat away as infrared light. But for a long time, you would just float there, warm, alive, and utterly disconnected from the rest of reality. You would be a ghost in a vacuum. James Webb has looked at the edges of these voids. It has looked at the galaxies that skirt the boundaries, and it has found that they are different. The galaxies in the voids are stunted. They stopped growing billions of years ago. They are time capsules because they are cut off from the cosmic web. They are cut off from the food supply. They have no fresh gas flowing in to make new stars. They are slowly suffocating. This confirms a brutal truth about the cosmos. Connection is life. Isolation is death. The universe is a network, and if you're unplugged from the network, you fade away. But the web itself is not static, it is moving. And this leads us to one of the most unsettling mysteries that modern cosmology has uncovered. A mystery that makes the crisis in cosmology feel personal. We are flowing. Our galaxy, the Milky Way, along with Andromeda and the entire local group, is rushing through space at 600 kilometers per second. We are sliding down a strand of the cosmic web. Where are we going? We are being pulled towards a region of space called the Great Attractor. It is a gravitational monster hidden behind the dust of our own galaxy, so we can't see it directly, but we can feel it. It is dragging us, but it gets stranger. When we look past the Great Attractor, we see that it is also moving. It is being pulled towards something even bigger called the Shapley supercluster, and the Shapley supercluster is being pulled towards something else. This creates a phenomenon called dark flow. It looks like a huge chunk of the observable universe is sliding sideways, pulled by something that might be outside the observable universe entirely. Imagine being on a raft in the middle of the ocean. You think you are sitting still, but then you notice the water is moving. You are in a current so wide you can't see the edges, and you are being carried towards a waterfall that is over the horizon, that is dark flow. Some theories suggest that this pull is coming from multiverse interactions, that another universe is bumping against ours, and its gravity is leaking through, tugging on our galaxies. James Webb is helping us map these flows by measuring the distances to galaxies with unprecedented accuracy. And the map it is drawing looks less like a machine and more like an organism. The filaments look like neurons. The clusters look like the ganglia of a brain. The voids look like the empty spaces in a sponge. But is it a living organism? No, it is a skeleton. Brian Cox often reminds us that life is the rarest thing in the universe. When we look at the cosmic web, we are looking at a structure that is 99.9999% dead. The gas in the filaments is hot and diffuse. The radiation is lethal. The voids are empty. The only places where life can exist are on the tiny, fragile skins of rocky planets, huddled close to stable stars, protected by magnetic fields. We are mold growing on a single grain of sand in the middle of the Sahara Desert, and yet we look at the Sahara and say, I wonder who lives on that dune over there. This brings us to a shift in perspective, a shift that hurts. For a long time, we thought the universe was made for us. We thought it was a garden. But the sheer scale of the wastefulness suggests otherwise. Why would a creator, or a simulation designer, or even a natural process build a universe that is 93 billion light years across just to house a few upright apes on one wet rock? It is the ultimate inefficiency. Unless the purpose of the universe isn't life, what if the purpose of the universe is just to be? What if the purpose is the fireworks, the black holes, the expansion, and we are just a byproduct? We are the moss that grows on the side of the factory, thinking the factory was built to give us shade. James Webb has shown us the factory floor. It is vast, industrial, and indifferent. And this indifference is what makes our existence so precious. If the universe was teeming with life, if every star had a talking planet, if the voids were full of spaceships, then we wouldn't be special. We would be common. We would be cheap. But if the voids are truly empty, if the web is just a web of fire and gravity, then we are miracles. We are the only part of the web that knows it is a web. We are the universe waking up and looking at itself. This realization brings us back to the detective story. We have surveyed the crime scene. We have seen the impossible galaxies of the dawn. We have seen the broken ruler of the expansion. We have seen the skeleton of the web. We have found no fingerprints. We have found no footprints. We have looked at the most ancient light, and it is natural. We have looked at the deepest voids, and they are silent. So, where are the others? The Fermi paradox, the question, where is everybody, becomes infinitely more haunting when you realize the true scale of the stage. James Webb has given us the ability to sniff the atmospheres of planets in other solar systems. It has looked at K218b, a planet that might have an ocean. It has looked at the TRAPPIST-1 system with its 7 Earth-sized worlds huddled around a red star. We are hunting for biosignatures. We are hunting for the chemical exhaust of life: methane, oxygen, industrial pollution. And so far, the silence is deafening. The midnight scholar has to ask, what if the silence is the answer? What if the crisis in cosmology and the Fermi paradox are actually telling us the same story? The universe is violent. It expands too fast. It collapses too early. It creates monsters in the nursery. It stretches light until it fades. It pulls galaxies into the dark in such a hostile breaking room. Perhaps we are the only ones who manage to stand up. As we prepare to close this investigation, we must take the evidence from the deep past and bring it home. We must take the terror of the Boötes void and the confusion of the Hubble tension and use them to answer the only question that really matters to a human being. What do we do now? If the universe is running away and the neighbors are dead or non-existent and the ruler is broken, what is our job? We are not conquerors. You cannot conquer a web that stretches for billions of light years. You cannot colonize a void. We are not explorers. We are barely out of the cradle. We are something else. In the final part of our journey, we are going to look at the only witness theory. We are going to synthesize everything James Webb has told us: the age, the violence, the speed, the emptiness, and we are going to find a purpose in the dark. We are going to turn the telescope around and look at the most mysterious object in the entire scan. We are going to turn the telescope around and look at the most mysterious object in the entire scan: us. When we look at the Earth from the vantage point of the James Webb Space Telescope, sitting 1,000,000 miles away in the cold dark of L2, it looks insignificant. It is a pale blue dot, just as Voyager saw it. But when you overlay the data we have just gathered, the impossible violence of the early galaxies, the tearing fabric of the expansion, the crushing emptiness of the voids, that dot stops looking insignificant. It starts looking like a miracle. The Midnight Scholar investigation has led us to a suspect we didn't expect. We thought we were investigating the universe, but we were actually investigating the conditions of our own existence. We have established that the universe is a machine designed to destroy structures. It pulls them apart with dark energy. It isolates them in voids. It blasts them with radiation from supermassive black holes. It confuses them with shifting laws of physics. And yet, here we are. This brings us to the final piece of the puzzle, the silence. For 60 years, we have pointed radio telescopes at the sky. We have listened to the hum of the cosmos. We have scanned billions of frequencies, hoping to hear a beep, a pattern, a whisper of mathematics that isn't ours. We have looked for Dyson spheres, megastructures built around stars to harvest their energy. We have looked for the chemical exhaust of industrial civilizations in the atmospheres of exoplanets. We have found nothing. The silence is the loudest sound in history. Before James Webb, we had excuses for this silence. We said, maybe we just can't see far enough. Or maybe they are hiding. Or maybe they are sleeping. But James Webb has stripped away those excuses. It has shown us the universe naked. It has shown us the dawn of time. It has shown us the chemical composition of galaxies billions of light years away. And in all that data, in all those petabytes of information, there is zero evidence of engineering. There is zero evidence of a level 3 civilization that has conquered a galaxy. The universe looks exactly as it should look if it were completely governed by blind, unconscious laws of physics. Now, ask yourself, why does that scare us? It scares us because it forces us to confront the possibility that we are it. This is the rare earth hypothesis, but upgraded for 2025. The old version said Earth is special because we have a moon or because we have plate tectonics. The new version, informed by the crisis in cosmology, says Earth is special because we exist in the only brief window of calm in a universe of chaos. Think about the timeline we discovered in part 1. The early universe was a monster. It was hot, dense, and full of exploding stars. Life couldn't exist there. The radiation would have sterilized any biology before it could divide a cell. Then came the era of nuclear synthesis, where the heavy elements were cooked: carbon, nitrogen, oxygen. You need those to build a body. But you also need time. We exist in a very specific epoch. We are late enough that the universe has cooled down and enriched itself with metals, but early enough that the stars haven't all burned out and the expansion hasn't ripped the galaxies out of view. We are in the cosmic sweet spot. If we were born 5 billion years earlier, the universe would have been too dangerous. If we were born 50 billion years later, the universe would be too cold and empty. We are not just lucky to be on Earth, we are lucky to be in now. This solves the Fermi paradox. Where is everybody? They haven't happened yet, or they tried to happen, and the universe killed them. The James Webb data suggests that planetary systems in the early universe were unstable. The gravity of those massive, dense galaxies would have flung planets out of their orbits. If you were a planet in Jade's GSZ 14.0, you wouldn't have a stable year. you would be tossed around like a ping pong ball in a hurricane. Life requires stability. It requires boring, predictable physics for billions of years. And as we have seen, the universe is anything but boring. So let's reevaluate the cosmic mistake philosophy. Brian Cox often says that we are a glitch in the thermodynamics of the universe. The universe wants to increase entropy. It wants to break things down. It wants to make everything cold and uniform. Life does the opposite. Life takes disordered matter, food, air, water, and orders it. We build complex structures. We write symphonies. We build telescopes. We are fighting a war against the second law of thermodynamics. We are a local rebellion against the heat death of the universe. And because the universe is accelerating apart, because the broken ruler is stretching the dark, our rebellion is doomed to fail in the long run. Eventually, the stars will die. Eventually, the protons will decay. Eventually, the silence will return. But that doesn't make us meaningless. It makes us essential. Here is a number that might scare you, but in a good way. The number of conscious minds in the observable universe is, as far as we know, roughly 8 billion, and they are all on this rock. If you average that out over the volume of the universe, the density of consciousness is effectively zero. We are a statistical anomaly so extreme that if you were a purely logical observer from another dimension, you would round us down. You would say the universe is dead. But we are not zero. We are one. And that one changes everything. If the house is empty, that means we own it. We don't own it in the sense that we can mine it or colonize it. We have already established that we can't leave. The distances are too great. The radiation is too high. The biology is too fragile. We are not going to build cities in the Boötes void. We are not going to terraform the galaxies of the cosmic dawn. We own it in a different way. We own the story. Without us, the universe is just a play with no audience. It is a beautiful, violent fireworks show that has been playing to an empty theatre for 13.8 billion years. The stars explode, but no one knows they exploded. The black holes collide, and the gravitational waves ripple out, but no one feels them. The nebulas form pillars of creation, but no one calls them beautiful. Until us. Until we built a mirror made of beryllium and gold, launched it 1,000,000 miles into the dark, and opened an eye. In that moment, the universe became aware of itself. This is the true function of humanity. We are not conquerors. We are witnesses. We are the nervous system of the cosmos. Through our eyes, the universe sees its own beginning. Through our brains, the universe calculates its own age. Through our hearts, the universe feels the terror of its own scale. This is a heavy burden. It means that if we destroy ourselves, if we let our petty squabbles and our greed wipe us out, we are not just killing a species, we are blinding the universe. We are closing the only eye that has ever opened. So, what does this mean for our future? It means we need to stop looking for salvation from above. No alien fleet is coming to save us from climate change. No galactic federation is going to invite us to join their club. We are the club. It means we need to stop looking for escape. Mars is a dead, radioactive desert. The moon is a grey graveyard. The exoplanets are unreachable. This realization, driven by the cold, hard data of the James Webb Telescope, forces us to look at Earth with a new kind of reverence. This biosphere, this thin layer of gas and water and green, is the only mechanism in the known universe capable of generating meaning. Meaning is not a physical object. You cannot find a particle of meaning in a particle accelerator. You cannot measure purpose with a ruler. These things only exist inside the complex neural networks of living things. If we die, meaning dies with us, the universe goes back to being a collection of rocks and gas. This is the Midnight Scholar's conclusion. We solved the case. The universe is a breaker of things. It is a vast, accelerating machine of isolation. And inside that machine, against all odds, a single flame has been lit. That flame is you. It is your ability to understand. It is your ability to love. It is your ability to look at a picture of a galaxy 13 billion light years away and feel awe. The crisis in cosmology is not a crisis of science, it is a crisis of perspective. We thought we were small because the universe is big, but the data shows us that we are huge. Because the universe is empty, we fill the void with our questions. As we look forward to the next decade of discovery, James Webb will continue to send us postcards from the edge of time. It will find more impossible galaxies. It will find more evidence that the laws of physics are stranger than we thought. It will deepen the mystery. But the central truth will remain. We are the librarians of the stars. We are the keepers of the record. Every time we discover a new galaxy, we are saving it from oblivion. We are giving it a name. We are giving it a history. We are making it real. The universe created us to document its existence before it tears itself apart. So, the next time you look up at the night sky, do not feel small. Do not feel crushed by the blackness. Feel the weight of your responsibility. You are the only one looking back. The galaxies are running away. The light is fading. The horizon is closing in. But right here, right now, the lights are on. The mind is active. And for a few brief, shining moments in the deep time of eternity, we are the ones singing it.